Thank you for attending the webinar, which we call Road Rehabilitation Faster and Easier Than Ever. My name is Tomáš Nendvorsky. I'm Senior Technical Sales Specialist responsible for AEC, Architecture, Engineering and Construction for Eastern Europe. And my pleasure is to support my colleague Viorel Kuhn, who is a sales guy, and he's also attending this webinar. The goal of this webinar is to show you what we have for road rehabilitation in our products. Because in fact, we did a similar webinar approximately a year ago, but since then a lot of things changed. We incorporated a lot of new functionality, which is really making road rehabilitation much easier. And the goal of this webinar is that I will present what is really new and kind of also compare it what was there previously. Yeah. So with that, I will start immediately. And obviously, if you are talking about road rehabilitation, this is task which is usually I don't want to say not very well paid, but really tight in budgets, And then the designer has to meet different standards like road type, design speed, pavement structures, etc., etc. And there is obviously a lot of constraints. It doesn't matter if you are out of town or inside of town, or especially inside of town or in village. You do have a lot of constraints like entrances and so on and so forth. And then obviously based on these constraints, designer has to really prioritize what is better in terms of design, what is better in terms of cost, in terms of benefits, and so on. And he must be, designer usually has to be pretty creative, so because he needs to decide which solution is the best, because okay, what is the higher priority, what is lower priority, cost, water, people, and so on and so forth. And definitely there is no typical section in road rehabilitation, because if you are designing new road, there is some typical cross section which you can apply from station to station, and it can go several hundred meters, then you are changing something. While in road rehabilitation, it's really changing. It can change even from station to station. And at this point, usually people are using some CAD software, plus Excel sheet, plus different stuff to really prioritize it. And if we are talking about road rehabilitation, it's a really decision-making process. If this is something like this, how it will look, and our solution is really supporting this. We are not proposing you some solution which is black box that you would push the button, road rehabilitation is done, and you can't do too much with that. No, we are really giving you versatile solution which will allow you to make your designing task easier, but still you as an engineer, you will make the decision what is the higher priority, and then you can really stand behind your design and you can explain why you made this decision. So, and what will be the agenda for this webinar? So at the beginning, I will talk about existing conditions. So it's always very important, and I must say for road rehabilitation, very important that you have really good and precise land surveying, that you have really good model of your road, and then you can base your design on really reliable data. Then we will have a look to the road rehabilitation, I would say the core of this webinar, how we are tackling this. And then I will be also talking about traffic simulation, because if you are doing road rehabilitation, you have to close the road, and then in our solution, we can also investigate or analyze what will happen in surrounding area if you close the road, how the traffic will flow around, where it will be congestion areas, and how you can avoid this. So let's say these are these three main topics which I want to cover during this webinar. So if we are talking about road rehabilitation, we have different tools which are really helping you to tackle this task. So if we are talking about point clouds, and here it's based on the point cloud, but I will talk also about conventional or classical survey. But regarding point cloud, so we do have functionality in software called Recap Pro, where you can process this point cloud or laser scans. Then we can move to the InfraWorks. We can extract the features because this is important for your road rehabilitation later on. So we can process the data, we can extract vertical features, we can extract horizontal features, terrain, etc. And then we can bring everything to Civil 3D, where you can make your design based on longitudinal profile, based on the cross sections, and you can see everything in at the very same moment. And after optimizing your, or better say, designing your corridor, you can optimize it. Basically, you can see what are the crossfalls, what are the subsequent gradient, for example, of the profile. And you can not only report it, but you can change it also in this tabular view or in view here. Basically, you have possibility to change it either in let's say interactive graphics or in tabular view. So it's really up to you what you want to do, what you want to achieve, and you will see it in a moment. So let's talk first about existing conditions. What are the existing conditions which you want to base your design on? So we have what I call conventional or classical survey, and Civil 3D can use, and you can import different sources which you will receive from surveyors' points, and it can be really in many different formats, as a text file, as a CSV file, as an AutoCAD 3D points, as a just simple text in AutoCAD drawing. So any or even blocks, blocks with attributes, for example. All this you can consume in Civil 3D, and you can build your terrain based on this information. So it's again a very versatile solution, and we are very open to any different type of data which we can absorb. And obviously, surveyors are not giving you only points, but also break lines. And again, they can give you 2D polylines, 3D polylines. 3D polylines, of course, are much easier, but with 2D polylines, we can also deal with. We have tools which can add elevations to these polylines to get really 3D polylines which you can use for design. And based on this, you can create your terrain. And I put here several dots because we have also what we call survey functionality, that you can import the data from survey stations directly to Civil 3D and base your existing terrain on that. And then we do have also possibility to absorb what is called point cloud. So basically, from laser scans, you can create your terrain, and then here I will cover what you can do with it. Because I believe that this is also a way where it goes, because first of all, it's much faster to do a laser scan on the existing road than to do classical survey, and you will get results very quickly. But obviously, and in this case, you will have enormous amount of the data, and you should be able to process it. So let's have a look how we can deal with this, that you don't have only millions and millions of points, but what to do with this. So for us, it's very important to have all this information, and then to be able to work with this. And here I'm just sketching what is possible with our solution regarding laser scanning. So we can absorb, or we can import the data from laser scans, but not only from laser scans. We can also import the data from photo. Basically, photo you can do with drone or with area photogrammetry, and all this data can be imported to solution which is called Autodesk Recap Pro, where from laser scan, what we can do, we can automatically register different scans together to have one homogeneous point cloud which you can work with. Or if you have picture, we do have cloud services where from the some amount of picture, because if you are sending drone, for example, above your road, so it's taking pictures in some regular interval, and then from these pictures, using our cloud services, we can produce point clouds as well. So, and then even you can have both. You can have laser scan of your road and then surrounding area made by drones, and then you can combine everything in Recap Pro. And then Recap Pro will produce the file format which is dedicated for our solution. So, and we can bring it directly to Civil 3D, to InfraWorks, to Revit, and all other solutions in our product portfolio. So this is the workflow, and let's have a look how it can look like. So basically, if we are talking about Recap can import many different formats provided by laser scanning companies who are really delivering data in specific formats like, for example, Leica, Faro, etc. So basically the Topcon, so basically the known producer of laser scans. So we can take all these data, or it can be even a generic text file, for example, but we can produce it. We can import it, we can process this scan. And basically what we can do scan registration, so we can put several scans together. We can make scan cleaning, the first cleaning, if there is some what we call noise in laser scan, we can clean it. We can do coordination transformation if needed. And then from this, we can export the data files, RCS or RCP, and these can be imported to InfraWorks. And in InfraWorks, we can do really terrain extraction, so we can produce just the terrain, and we can extract vertical objects. Basically, these will be different objects. We can do linear extraction, we can produce cross sections, and all this data we can take and bring it to Civil 3D. And not only this, I made here also classical survey, because if you have some combination of point cloud and classical survey, we can very easily combine everything in Civil 3D and make finally a road rehabilitation. So let's have a look what we can do. So we can import clouds. So we are in Recap Pro, and I will import point clouds. And here are just laser files which I will bring in, just drag and drop to the new project, and system will import it. And then I told you that you can make a transformation of coordinates. So basically you can say, okay, current is UTM 84. And I want to convert it while importing it to the different coordinate system. So you can do everything in Recap, and then these file scan files will be processed and imported. So this process will take a while, because you should realize that we are talking about millions of points, so don't expect that it will be done in 1 second, but it's not a long process. So you can see that the system is processing this data at the background, making all necessary registration, and after everything is done, you can launch the project and you can view it. So this can be a result of your laser scan of your existing road, with also some what we call, as I said, noise. So basically you can see that there were some car passing by while a measurement has been done, but all this kind of stuff can be clean here in Recap, because we do have functionality, for example, to delete parts, to clear stuff, and so on and so forth. So this is part done in Recap, and then afterwards you can, after cleaning, you can bring it to InfraWorks. And in InfraWorks, what we can do, we can have a look to the model properties, and obviously we will define the same user coordinate system that we are at the same page. And by the way, at the background, just to be 100% sure I'm in correct location, I brought in the data, which, by the way, can be created for free using what we call Model Builder in InfraWorks, to have really good understanding what's going on. And then what we can do, you can bring this data in. which we in fact process in recap, and I can bring here this data about highway, about motorway, better said M62, and this can be visualized, and then I'm 100% sure that I'm in the right location and everything is fine. So just always double checking if everything is fine, and system will connect to the data sources and bring the data in. And again, just you have to realize that we are talking about millions of points, and the processing will take a moment, but this is not really a long time comparing the amount of data which we will bring in and which we will use. So now processing the data and seeing what's going on. So bringing data in and have a look. The result is immediately here, or better said after a short while. So if I zoom in, as I'm zooming in, you can see that the system is showing my point cloud data based on existing terrain. So I have data in, and now what we can do with this. So, and you can see that even though we have millions of points, we can work with this. And first, what I will do, I will create terrain. So basically, what system is doing, because you don't have only terrain here, but you have here what you see also vertical features like trees, lampposts, traffic signs. And in fact, we can basically our system can optimize it, and it can automatically recognize where the vertical features or vertical objects which will be automatically removed. And at the end, I will receive only pure ground, where my road is. So you can see at this point, I have terrain. These points are, so if I will right now point clouds remove, so I have here this terrain and everything is here. So I can make something visible, something invisible, like similar like in AutoCAD. In fact, I can work with this and I can see what happened. And all these vertical features which you can see as a points has been automatically removed, and I can see only terrain, which is obviously very important. So maybe if there is some overpass, it has been also removed automatically. Here you had some noise as the cars were passing and so on and so forth. So all the information are here and we can work with this. And then we can also work what we called with linear features, because I mentioned, okay, having terrain is good, but what I would like to have is also where is the center line, where is edge of the road, where is edge of the curb, bottom of the curb, top of the curb. So I will specify the style, and now here I have, for example, a center line with road markings. So, and I will click 2 points. And because it's set to automatic, so system is going through my design, or better said, through my point cloud, and finding where is my center line, based obviously on some mathematical calculation. And you can see that he found this center line up to here because it was marked up to there. Yeah, and you can continue. You can create, for example, here you have a widening of lane, and similar way you can create another feature line automatically. So I will say, okay, now I want to go this, for example, different or the same style, whatever. So I will click from here to here. System will do automatical horizontal line extraction and having it here. So you can go through this and you can play with this very easily. And to find, and this line was really long because this was very well marked, and system can follow it very easily. Yep. So Obviously, manual style means that you would be able to click it. It's just much easier and faster doing this way. So after having this point cloud extraction of feature lines, we can check it in cross section, because obviously there might be some noise and system can jump suddenly. So now I can visualize these horizontal feature lines in my cross section, and I can say if it's, for example, missing, or if it's not correct. I can say, okay, I want bottom of the curve and top of the curve here. And in fact, in this particular cross section, I am specifying where the location will be, and the system will do extraction for me. It's another way how to make extraction. Yeah, and again, so I can specify will be the bottom of the curve, where will be the top of the curve, and I can go from cross section to cross section, and you can see that the system is drawing it, and the system is trying to find it again for me based on the information. So I specified in the first cross section, and then I'm going through cross sections, and I can check if system is creating it correctly. If not, I can move it. In each cross section, I can move it, and I can correct what system is doing, which is very important. So as I said, it is not black box where you don't have control over it. You can choose the way how you want to create it and how you want to proceed with this. Yeah. So this is the way how you can do it as well, and how to correct it. And then if you have this information, what you can do, you can produce, for example, cross sections. Basically, you can prepare cross sections which you can later on use for designing purposes. So basically, you will have cross sections through existing round. You will say, okay, every 7 meters, how many vertices you will have, and what system will do. System will create these cross sections which you can bring to Civil 3D as a result. So generating traverses, having this, and this is something which I can bring. I can bring entire point cloud, but maybe this is easier like this, and you can make decision what you want to bring, if terrain or vertical features or horizontal features, and so on and so forth. So what are the benefits? We can consume any data, including GIS data, conventional survey, laser scanning, and we do have tools to deal with scanning data, process drones, laser scans, horizontal line, feature lines, cleaning point clouds, and so on and so forth. So you have a really wide range of data which you can bring and which you can use for road rehabilitation. And we are moving to this, let's say, core of this presentation, what is road rehabilitation. And road rehabilitation, there is many different types. So if you need to do some design speed improvements, you will have to redesign alignment and profile. You will have to define super elevation, maybe some widening, and then later on daylighting to the existing route. It's really maybe something which is, this is not called, I wouldn't call it resurfacing, I would call it road rehabilitation. But then you have resurfacing, where you are just basically milling what is already on the road, and you have to add something on the top. But at the same time, you can obviously create alignment. Maybe you want to do some slight changes in profile, etc. Or it can be a mixture of both, because in some parts of the road you want to make resurfacing, and in some parts you want to make design improvements. And we can meet both of them, and we can easily mix it. And if we are talking about Civil 3D, this is what we have here. So regarding alignment and profile, we can use what we call best fit. So basically, system can find best fit line, best fit curve based on existing points. Using least square method analysis, we will get results. Then we can we have to define sub-assemblies, basically the typical road cross sections. And we do have dedicated sub-assemblies which are for really road rehabilitation, or we can use standard sub-assemblies, or what we have also possibility to define sub-assemblies in some specific editor which we call sub-assembly composer. Then obviously we can model the road, we can check cross sections, cross falls, and based on this we can make decision. And at the same time, we can do reports in different formats as a numeric output for each cross section, or we can visually see what is the amount of milling. We can annotate it, for example, in layout to see how much milling we did in some specific parts, how much has to be removed, and to have really better understanding what we did and how we can improve. Because again, road rehabilitation is kind of iterative process. So talking about alignment, I said that you have a possibility to create best fit alignment, and then you can design really straight and curve based on analysis made by system. So have a look how it can work, what we can achieve. So here I have from laser scan, I have road center line, edge of the road left and edge of the road right. And now I will say, okay, this is my center line, and I will use functionality best fit line. And you can see based on standard functionality, it can be fixed, it can be floating, it can be free based on points. And now I will be just clicking on the screen, and I will be picking the points on the screen and showing how it works. Or you can take usor that is there. If I have, for example, very well defined center line from here to here, I will say, okay, bring this polyline and do this. And as I'm clicking the points, immediately you can see that system is doing best fit analysis, and he's creating this line. And now I can see also basically what is the distance or offset to the entity from my best fit. So basically each point, for example, this point is 0.4 meters, which is pretty far away. So now I can make decision which points I want to keep, which points I don't want to keep, because maybe there is some mistake in survey. So I can say, okay, I can exclude the point, and I can see immediately, okay, I exclude this point, and what will be the result? Immediately system is recalculating everything for me, and I can really find the best fit in fact straight at this point, and I can continue with this. And then I can go and let's create a floating curve, because it must be floating to this existing already straight. And now I will be clicking another points which are defining measured in curve, and system will do analysis for me, and I will get immediately as before results. I can see offsets, I can specify which points should be passed through, which should be excluded, and so on and so forth. Basically, this is the way how we can create best fit alignment. Or as I mentioned, we can do also, for example, if you have polyline, we can convert it and system will make spline line if you are fine with it, if you don't need some parameters. And a very similar way we can do it for profile. But now let's move to the corridor. If you have alignment and profile, you can go to the corridor. And we have two types of corridor. We have standard corridor, or we have very new one, which is called rehab corridor. And as the name suggests, it is really dedicated for rehabilitation. And then we have to apply subassemblies, or better said, assemblies created from subassemblies. And this is standard. So basically we have a wide variety of standard subassemblies which you can use. And here I'm to the standards, I'm also including specific subassemblies created for rehabilitation. Or we have dedicated what I call rehab subassemblies, which are dedicated for rehab corridor, and you will see the process how it works. Or we can use subassembly composer, where you can build your own subassembly based on your requirements. So if you are talking about standard subassemblies, they are very rich, and you can do overlay, milling, leveling, widening based on rules, matching the slope. So basically you can see that it can match slope which has been designed, and it will be making widening with all layers, because here is, for example, already existing pavement, and you are just making widening. You can see the very similar here. Here is how it makes, how system is doing with leveling, with overlay. Obviously, if there is millings, so system will scarify part, and so on and so forth. These are the standard subassemblies for standard corridor, which in fact I showed last year. So this is not new. Then I also talked about subassembly composer, where you can have a visual programming, where you can build your own subassembly based on rules, based on some decisions. This is really visual programming. You should understand the logic, but you don't need to know programming, because in fact you are just dragging and dropping nodes and making connections. But then we have something which is really new, and which are rehab subassemblies, and they are really newly developed for a rehab corridor. And you can see you have overlay and level, overlay mill and level, based on crown road or one side road. Is really you can choose what you want and how you want to achieve. And here are just some visual how it looks if you do, for example, milling and leveling, overlay, leveling and overlay, and everything together. So basically you have different possibilities how to combine it and how it works. And this is what I was talking. This is the very new part, and it's really making rehabilitation very easy. And the system, in fact, is driving you through the process what we can do. So let's have a look what we can do. I have the center line, I have left edge, right edge, and now I will call rehab corridor, new functionality. Obviously, I should define what will be the name. I will do first 1000 meters based on alignment, and profile is just profile of the existing ground, nothing else. So at this point, I didn't define some profile with parameters. And the system will automatically create 3 different views for me. So cross-section view, which is empty at this point, longitudinal profile, and layout. Everything based on standard. Again, don't forget that Civil 3D is using what we call the template from Country Kit, and then everything is drawn according to this. So, and let's have a look here. So if I want to do resurfacing, maybe I want to keep myself just within these existing edges. So you have here possibility to define offset, line width for the left. So just note here it's left line, yeah. And now I will say, okay, I want to limit myself only within existing road. And what I will do, I will click here, in fact, feature line, which I extracted in from point cloud, and I will say, okay, my resurfacing will finish here. And the same I will do for the right edge of the road. So I will specify the line which is coming from survey. Or you can obviously say, okay, it will be 3 meters, 4 meters, whatever is the value, and system will do this. Then another important part is property. So basically you can specify what is called slope tolerance, lane break, and so on and so forth. So I will stop here a little bit. Just have a look. Slope tolerance. You will tell to system if tolerance is 0.5% or whatever is the value, so then I am fine. And system will not use ideal crossfall, but he will apply also ideal crossfall plus minus this tolerance. So basically we are doing what is called also flapping, so that you are minimizing the amount of stuff which will be added. And then you can also specify lane grade slope limit, basically what is the maximum break between 2 subsequent slopes of the cross section. So you have control how system should behave, yeah. Or relative gradient, it's related to the center line. So you can define all that kind of stuff. And then here we are going to this subassembly. So from here you can say if you want level only, milling and level, and you will specify the values for overlay, for milling, for leveling. So basically based on the value you will specify the values, and based on this system will automatically create assembly for you, and he will apply the values. So one click and kind of deal done, So I have already here cross section, and I can obviously see what's going on where I am in longitudinal profile, in cross section, and I can go through this and I can move around and to see what system did. Yeah. So And in fact, we have what we call station tracker. Doesn't matter where I will move, if I will move in horizontal, vertical, and you can see what's happening. If I had some bumps here, system is giving even warnings that something is wrong here, and giving me the warning that maybe I am not really meeting defined criteria. Yeah. So going through the cross sections, I can have a look and see what's going on. And obviously, it's very much depends on the survey which I receive from land surveyors. Yeah. So let's have a look that minimum level depth is not sufficient at this point, or overlay depth. So I will put much more. So hit apply, deal done. And you can see system will do scarification, then leveling, and then overlay. And visually I can see where I will be and what is the result. Yeah. So immediately it has been applied to my station range, basically to this 1000 meter. If you remember at the beginning, I said from the 0 to 1000 station. And you can see you can play with this. Don't forget that in Civil CD I can apply region, so I can say, okay, do this one from this station to this station and something else in different region. It's really up to me. So it's entirely in your hands. And then we can also open a rehab manager. So basically here in values, I have all information related to the particular cross section. So if I'm in cross section number 125, so station 125, I can see what is my crossfall. And again, everything is connected. Cross section view, longitudinal profile, layout, and even this report. So basically, I can move and I can change even the value. So I see the difference, what is the corrected slope, what is the optimum slope. And then I can go here and I can say, okay, accepted slope, this is something which I want to define. So I have the possibility to define value here, and the system will do it for me and immediately recalculate it, and you see the result immediately within within this table what was going on in the particular cross section. So system at the first moment, he went through entire region of the corridor and did it for you, but now you have the control over each and every cross section. You can check it and you can view it. And now, for example, I decided, because what I would like to see, I would like to see values not only in this tab, but also I would like to see it in cross-section view. So basically here I am using style where I see elevations, crossfalls, etc. So maybe not showing hatching. It's really up to me, because it's defined by some code set style which is user definable. And you see, I see these values. I will modify it. So I will say, okay, 2.1, done. Yeah. So you see that I change it for the left-hand side, and it's really immediately visible here. And then you have also a milling and leveling report, which means that I will get exact volume tables for each and every layer, and I can check it. And this is really an iterative process which you can use and which you can improve from station to station. And then talking about reporting, you saw it, we have this milling and leveling report with all values which are important for me. But then I can also make standard reports where I have XYZ coordination for each point. If cross sections, I see what is this, if it's left-hand side, right-hand side, central line, which I can in fact give for automatic guidance machines that they can work with this, and they can bring it into their machines. Or within Civil 3D, we have also other way of analyzing it. So I can display volumetric report based on cut and fill. I can visualize it in different colors, in different values. And here is something what we call heat map. If I want to display how much overlay I will have or how much milling I will do, I can tell, okay, if it's 1 centimeter, it will be some different color. So basically I can have this analysis and I can display it. And also then I can add dynamically points And don't forget, if it's iterative process, if I will change cross-section, these values and these colors will be changed automatically for you. So you can see immediately what is the consequence of your change. So what is the benefit of having such solution? It's really versatile, very versatile solution. You can change it in longitudinal profile, in cross-section view. You can see immediately what is the impact of your change to minimize the cost. And it's everything based on the dynamic model. So change in one location is automatically propagated through entire model, which means to the other drawings, cross-section views, analysis views, volumetric calculation. And it helps you really to automate the rehabilitation design. I am not saying this is one button push, because this is something which designers would like to have, but in reality they should have control over what they are doing. And I promise that I will also show you traffic simulation, what we can do in fact InfraWorks. Why traffic simulation? Because if you are making road rehabilitation, you have to close the road or close the lane, and then obviously there can be a lot of angry drivers which are stuck in the traffic jam. So what we can do in InfraWorks, in fact, is a traffic simulation where we can analyze the flow of the complex system. In this case, it will be roads around the road closure. You can identify problems areas. You can visually see what's going on. You can change, for example, the behavior. You can change the junction. You can change the lights, and so on and so forth. And again, you can check results to really design or suggest the best solution. So, and let's have a look what we can do. In fact, we can very easily create the existing terrain using the model builder, and in fact, after bringing data in, you can open the model. And here is what you will get, for example, for the specific model. It will download the imagery. And this you can get in really very quickly in a moment. You can receive such a model for analysis. You don't have to do anything, just wait 3 minutes and you will get this one. And then what you can do, you can define what we call demand division, because each road is different, and you should define what will be the percentage of small cars, medium cars, large cars, SUV, trucks. And mainly these trucks are important because they can slow down traffic, because they have different behavior while driving. Then you have demand editor, where you are specifying how many cars will be traveling in between specific points. So you will define the amount of cars or vehicles which will be traveling. And then you have intersection control. So you have the way of defining what will be the behavior. And that's it. So let's have a look how it works. It's, I would say, easy 3-step process, and you can work with this. So let's have a look here. I am rehabilitating this road. So this road will be closed, and I will be checking what will happen in surrounding area, how people will be affected in the villages around. So within InfraWorks, we have functionality to define what we call traffic area, which I'm interested in. And then we can go to traffic simulation panel, where traffic analysis panel, sorry, where you can define all what I was talking about: demand division, demand itself, and also you can define the behavior of intersections. So just like in AutoCAD, you can have different layers, visible, invisible, so which I did just right now to make it more visible for you. And I will say, okay, this is my demand division. So for vehicles, I will say what will be the percentage, what percentage I expect. So maybe I expect here more trucks, so I will say 30% of trucks, so which will reduce maybe large or medium cars, you know. So you can really define it as you wish. So maybe 50 is too much. So let's say 30 is really right value. Yeah. So then you can go to the demands, and you will, or better said, I will specify what I'm expecting, how many cars will be traveling between points. And you can see if I zoom out, so if I click here, so I see that I'm specifying how many cars will be traveling from this point to this point, and now in this particular area, yeah, to point number B, because each point, yeah, cars will be traveling from here to here, how many cars will be traveling from there to there, because these are the main roads, so I expect that there'll be bigger number of the cars going here and going there. And by the way, this number of the cars depends on the time which you want to analyze, which can be 10 minutes, it can be 1 hour, or it can be more 3 hours, so depending on the analysis which you will be doing, you will specify the number of the cars. And now, if I'm talking about one specific intersection, you see that I have even the names of the roads, because from GIS information we got the name of the roads, and then I can specify which signalization is there or will be there. It's my decision. So I'm saying it will be stop sign, free flow, yield sign. So I am defining what is there or what will be there, and I can apply it. Yeah. And then based on this, I can start to make analysis. The same I can do for the different junction. So I did this one, and the similar way for this junction. But now here, in fact, I define that it will be signalized. There will be traffic lights. So a little bit different behavior. So I put it to different groups, and I specify timing for green, yellow, red light. So you can specify, what will be the time here. So 50 seconds, for example, for this direction, and less timing for this direction. So really, what you want to achieve, or where you expect more cars, more vehicles traveling in the direction. Yeah, applying it, hitting OK, and everything is ready, and I can view the simulation. So basically, now I can see how the cars are coming, and obviously, you see that I did short morning, which is 1 hour. Yeah, 1 hour is here. So you can see that the number of the cars obviously at the beginning is not too much. But as time is proceeding, so and there is red light, so people start to queue. Yeah, because more and more car is coming from this closed road. They have to wait, and then they continue after having this red light. So they are continuing here. So again, you can see here that vehicles are waiting, and you can see also this demand. So you have big vehicles, small cars. So really, behavior, the driving behavior is the different. So, and then if I see that something is going wrong here, so I can say, not very good solution. Now I want to respecify something, because you can see that people are queuing here and people are queuing here. They are even making obstacles in junction, which is not a good solution. So let's change, for example, this junction, and we will go to control, and I will say, okay, maybe I want to change something here. And now there will be no signalization, but I will specify only fixed signals, and obviously to this main traffic flow, I will give free flow, that cars can traveling freely, and obviously other cars will have to wait. And then I can again analyze and see the different alternatives of my solution, what will be the behavior, and I can really iterate the best solution, because obviously changing something in one intersection will have subsequence in another intersection. So I will hit apply, and I will rerun analysis, synchronizing with cloud, and rerun analysis, and I see, okay, now there's free flow this direction, and here cars has to wait. So really, you can, based on your best judgment you can do what you want. And obviously I have trouble here, so I will go to change this traffic sign, this signalization, and you see that maybe it's better solution. So as I said, iteration of your design. And then what we can do at the end, I can close it and I can go to my InfraWorks, where I can visualize the result, because this maybe I want to present somebody. Basically, I want to present to the people. So I will say, okay, right now, show me my short mornings and run simulation. So system will run simulation, and it will basically bring the data from cloud where it has been analyzed, and now I can visualize it and I can play it. So I will say, okay, play it this speed time, 10th time. So after 8 minutes, you can see what will happen. Yeah. So you can visualize what's happening here. You can see how people will be queuing, where will be the problems. So this is something where we want to go. So benefits. Existing road you can do very quickly for free, so you have a really network of your road very quickly. It's a really easy 3 steps definition of traffic analysis. You can very easily visualize the results. You can do different alternatives, and then you can easily present why it should be like this and why you made this decision. So with that, we have 5 minutes more. So what I will do, I will ask you if you have any question, if you could type it to your chat window, that I can answer it. Or obviously you can see here my email address, and please if you have any question later on, do not hesitate to contact me. So maybe what I will do now is, if VRL wants to say something, so VRL, I will give you, I will unmute your microphone. So if you want to say something, you can go ahead if you want. Okay.
Bună ziua! În primul rând vă mulțumesc pentru că ați participat la webinar. Vreau să-i mulțumesc și lui Tomaș. Vorbesc în română acum pentru cei care vor să exprimă mai ușor în limba română. Noi le stăm la dispoziție, da? Pe e-mail sau pe adresa de e-mail lui Tomaș Lendorski sau a mea. Orice întrebare, orice nelămurire, noi vă stăm la dispoziție. Ok, vă mulțumesc frumos. Numai bine. So thank you, Tomasz. I just thank everyone in your name and mine. So if they have questions in Romanian or English, they could write to us or ask us now. Yeah. Thank you again.
Sorry, I just type your email address that they can also write you. But whatever, So guys, please feel free to contact either me or VRL with your questions. Yeah.
Thank you, Tomasz.
Pleasure. So, guys, I hope that you got understanding what we are capable of doing as far as road rehabilitation is concerned. So I just want to quickly summarize that we believe that we have right tools for road rehabilitation. And obviously, I want to stress this is not a one-button solution, because road rehabilitation is not about one button, but we do have versatile solution which is allowing you to make your design quicker and faster, and really evaluate the different possibilities, different options, and to really be clear later on why you did this decision and what will be subsequences of having different solution. So you can really iterate your design much quicker and being solid about your decision. So with that, thank you for your attention, and please do not hesitate to contact us, and we are ready to help you in the future. So with that, thank you very much, and have a good day. Bye bye.
Thank you, Tomasz. Have a good day.